Presumably you've seen how the sine law was developed, and you recognize that, hey, the sine law is great because you can use it to solve for lengths and angles in triangles that don't have a 90-degree angle in them, that aren't right triangles. So here at the top, you see that this sine law turns out to be this kind of three-part thing. We only ever use 2 parts at a time, right? So for example, you might set up a sine law that says sine A equals, or sine angle A over side A equals sine angle B over side B. Of course, remembering that the small letters are the sides opposite to the vertices that have the capital letter for that angle. So that's one thing you might do. You might also say, for example, that I want to set up a sine law using sine A over A equals sine angle C over side C. It depends what you want to find. So generally speaking, I would say you would use the sine law when you have 2 pieces of info, what I call 2 pieces of opposite info. By that I mean you would have angle C and side C, or angle B and side B, or angle A and side A. That would be 2 pieces of information that you would know. You would also need, of course, then plus 1 other piece of information. So you would know either 1 more side or 1 more angle. And then you would use the 2 parts of the sine law that make sense. So in the example that we have here, we've got a triangle, non-right angle triangle, at least it looks so. We happen to know 2 angles, and we know 1 side. Looks like we have 2 opposite pieces of info. We have angle C and side C. So that means I'm definitely going to be using this part of my sine law. Makes sense because I have these 2 pieces of information. I also have this piece of information, that angle A is 65 degrees. So it looks like I'm going to set up an equation that looks just like this. Because I have this information, I have also this information, it looks like I'm going to solve for side A. So I'm going to set up my equation. The 2 parts that I need are sine A over A equals sine C over C. I will fill in the fact that I know that A is 65 degrees. I don't know what side small a is. Sine C here must be sine 85 degrees. And side C is 12 centimeters. I need to solve for A, and you know that we can never solve for something that's in a denominator. So we're going to have to get this thing out of a denominator. I do that by the simple process of cross multiplying, by which anything that's in a denominator down here goes up there, this denominator goes up there if I need to, anything up here can go diagonally down across there. If you know how to cross multiply, that's great. If you don't, the process is that I'm really just going to multiply both sides by A, and that will cancel A off of this side, in which case I will have sine 65 equals sine 85 degrees times A over 12 centimeters. Now I want A by itself, so I'm going to have to as well get rid of the other 2 things. The sine 85, I'm going to divide both sides by sine 85, so that will end up down there. I'm going to multiply both sides by the 12. I won't show you me doing it, but it's fairly simple. And so this is just a whole bunch of rearranging, and I'll end up that A equals the sine 65 that's there times the 12 centimeters divided by the sine 85 degrees. So I just need to do some punching into my calculator. 65 sine times 12 divided by 85 sine equals approximately 10.9, and I would guess that would be in centimeters. Now we've found side A here, and it's 10.9. We could because we had two angles, we could have just as easily figured out side B, because given the fact that we know that angles in triangles always add up to 180 degrees, 65 and 85 make 150, so this must have been 30 degrees. So maybe just for really quick practice, let's see if we can find side B. That would be easy to do. We would set up, I always use the information that was originally given to me. I could set up an equation using sine A and sine B, but that would use this number here, the number that I've calculated. I don't want to throw off my accuracy by using a rounded off answer. So I'm going to set up an equation using these two, sine B over B and sine C over C, and that would make sure that I would get a nice accurate answer. So I'm going to set up the fact that sine B over B equals sine C over C. I will fill in that sine of 30 over B, which I'm looking for, equals sine of 85 degrees over 12 centimeters. Okay, so just doing some quick cross multiplying, I'm going to have a B up here. Right, 12 is going to go up there, sine 85 is going to go down there, so I'll have 12 times sine 30 degrees over sine of 85 degrees, and on my calculator, 12 times sine 30 divided by sine of 85, and I get a number of around 6.0. So it looks like side B here must be 6.0 centimeters. Right, and I was assuming that this was 30 degrees. There you go, using the sine law.